Graphing Linear Inequalities, Part 1. In today's lesson, students will learn how to graph linear inequalities. Linear what? Very good. So we're going to take a look at how to graph linear inequalities. What's an inequality? Let's remember, okay? We remember that it was more than, right? It was more than to the right or less than left, okay? So when you look at a linear inequality, that's going to be a line. And more than, okay, more than is not going to be to the right anymore, okay? More than is going to be above the line. So if you say more than, you're going to say above, okay? So say more than, above. Now when you look at less than, because we've seen this before, okay? Instead of less than left, we're going to say less than below. So say it with me, say less than below. So let's take a look. Remember your mama's ex-boyfriend. The equation we're looking at right now is y is, what is that, more than or less than? Yeah. Y is more than negative x minus 1. So when you go to graph a linear inequality, you are going to look for the same two variables you always look for, and that is m, okay, which is the, what's m? M is the slope. And then you also look for b, okay? B is which variable? It is the y-intercept. The y-intercept is on which axis? It's on the y-axis. That's right. Okay. So you're looking for M and B. Very, very simple. So all we're doing really is graphing a line, but we're going to do something different with this line. Okay? The line is going to be dotted. It's going to be what? Dotted. Exactly. Okay, because it doesn't include the line. We're either going to actually shade above or below the line. Let's see what we're going to do with this line. It says y is more than, so you say more than above. So when we make this line, we're going to shade above the line. So let's take a look at what the slope is here. Oh, is there something invisible here? Yes, it is an invisible 1. Actually, it's an invisible negative 1. So we're going to write that the slope is negative 1 over 1 or 1 over negative 1. That's right, okay, because there's one negative on each side. So you either can go down and over 1 or up and to the left 1. The y-intercept is, what's the y-intercept, my friends? The y-intercept is negative 1. Okay, so you're going to start with the boyfriend, which is the y-intercept when you go to graph this linear inequality. You're going to start at which axis? The y-axis, and you're going to put a big dot on negative 1. From this point, we're going to take a look at the slope. Why don't we go down 1 and over 1 first? Down 1, over 1 to the right. Then let's use the other slope, up 1 and to the left 1. Now, before you connect the dots, I'm going to tell you, because it's an inequality, it means it's not equal. What does inequality mean? Not equal. So because it's not equal, the line is broken up like this. It has a negative slope, which you're going to dot that line, dot, 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 okay? Now, let's talk about shading, because with linear inequalities, you shade. Now, usually, if it's an equal sign, any dot, any point on the line is a solution. But here, it's not going to be. Here, because y is more than means, right? More than, hold on. Yeah. More than means above. So you're going to shade, this is above the line, this is below the line, okay? So you're going to go ahead and shade above the line. Let's see what that means. Let's choose a point. Let's choose a really simple point. Why don't we choose 3, 2, okay? So this is a point that's in the shaded region, 3, 2. And let's plug it into the linear inequality. Let's say, okay, if it's 3, 2, this is x and this is y. Is that right? So we're going to plug in x and y. 2 is more than -1 times, what's x? X is 3 minus 1. Let's see if that's true. Is 2 more than, what's -1 times 3? -1 times 3 is -3. Minus 1 more. So it's saying is 2 more than -3 and -1. Those are same signs. So you say same signs, add and keep. So that's going to be a -4. Is 2 more than -4? Is it true? Yes, it is. And any point that's in the shaded region is going to make this a true statement. Okay? If you were to choose a point that is under the line, it would be different. Let's choose a point that's under the line. Why don't we choose -2, -1? -2, -1. Okay, so I'll say y is more than -1, x minus 1. Let's plug in x and y. Okay, so we're going to plug in x and we're going to plug in y here. So if we say, okay, -1 is y, right? What's y? It's -1. -1 is more than -1 times -2 minus 1. Here we go. So -1 is more than, let's solve. What's negative times negative? Positive, right? So -1 times -2 is +2 minus 1. Is -1 more than 2 take away 1? What is 2 take away 1? Is 1. Is -1 more than 1? No. And that's why it's not part of a solution. So any dot that is under this line or below this line is not going to make this statement true. Okay, let's do another example. Let's do example 2 on your paper. Read the linear inequality with me. It says y is less than 2/3 x plus 2. So we know that less than means below the line, right? So say it with me. Less than is below, all right? So we need to identify two variables. What are we going to identify? We're going to identify the slope and we're going to identify the y-intercept. We're going to identify what? The slope and the y-intercept. That's right. So we look at slope. Slope is m. Y is more than mx plus b, your mama's ex-boyfriend. And the slope is 2/3. Is that right? Okay, so it's 2/3. Or, now positive. What makes positive? Negative times negative, right? So it could be -2/3. You have to have two negatives to make something positive. Okay? And then your b, or your y-intercept, who knows what the y-intercept is? What is it? It's being added to the linear term. It's 2. So we're going to start with 2 on the y-axis. So let's make a dot at 2, which is here on the y-axis. All right, from there, our slope is 2/3. Is that right? The slope is 2/3. So we're going to go up 2, 1, 2 over 1, 2, 3. You should be at 4, 3. Or you can go what? Down 2 and to the left 3. So let's go down 2 over 1, 2, 3. Okay? Are you just going to connect the dots? Or do you have to do something special to the line? What do you have to do to the line? You have to make it dotted, right? It doesn't include the line. All right? Let's go ahead and make a dotted line. Now, Ms. Cotran, why is the line dotted? Why is the line dotted? Well, I'll tell you why. Let's choose one of the points on the line. Remember how I talked about this point is 4, 3? Choose one of the points on the line. Okay, so 4, 3. If we plug in 4, 3 into the linear equation, okay, 4, 3. Remember, y is less than 2/3 x plus 2. Let's do that. So this is x and this is y. So if I say 3 this is less than. 3 is less than 2/3 times 4 plus 2. Wait, divided by 3. Oh, no, I don't want to do that one. Let's see if I can choose one where x is 3. Okay. So let's choose a point on this line, and I will show you why this is not a true statement, and it doesn't include the line. So let's choose this one. This is negative. You should be at negative 3, 0. So if you're at negative 3, 0, this is x and this is y. Is that right? So let's plug in x and y into the linear inequality. We're going to see, is 0 less than 2/3 times negative 3 plus 2? Is that true? Let's look. Is 0 less than? Okay, you have a 3 and a 3. What happens when you have a 3 at the top and a 3 at the bottom of a fraction? They cancel out, but you're left with negative 2 plus 2. All right. What is negative 2 and a positive 2? They make 0. Is 0 less than 0, my friends? Is 0 less than 0? No. So this point cannot be on the line. You see what I'm saying? So it has to be dotted because it doesn't include it. So let's talk about all the points that are included in the solution to this line. So this is less than, so it's going to be below. Below the line is like this. Okay, this is below where this would be above. So we're going to go ahead and shade everything below the line. Okay? And that is an introduction on how to graph linear inequalities.